So again, number 3 is not congruent because the parts don't match up the way they have it named. So make sure if I give you the congruency statement, you read the way it's named and check it. All right, number 4 made ASS. Were y'all fine with that one? Okay, so y'all said number 5. Everybody look at 5. A lot of you marked these 2 angles. Those are not vertical angles. If you flipped this one, it would be down here somewhere. Those aren't vertical. Does somebody need me to like draw an example so you can see where they're vertical? There's one right here where they're vertical. They're straight across from each other, 180 degrees. That's not 180. Like from here to here, that's probably like 130 degrees. Not vertical. So all I gave you for this one is the right angles right here, and you know these sides are congruent. That's it though. So if you look at one triangle, we only know one angle on one side, and that's it. So that's not enough info. So that's not congruent. Number 6 was named right. So I put side angle side. Did y'all check and make sure that they had the corresponding parts lined up? 7 was also side angle side if you checked the parts. Any questions on the first page? Surprisingly, y'all struggled more on the front than on the back. I thought it was going to be the other way around. People at home, are y'all good with the first page? My people in class, make sure you're changing yours if it's wrong. Some of y'all didn't even draw the triangles, and that's going to come back to bite you in the butt because a couple of these I put on the test as well. So I got some of y'all that haven't been taking your notes or writing down your problems, and then you can't use them. Like if everything's open notes, I would make sure I wrote down every single thing from class to use it. All right, moving on. 3 through 7. I'm going to pause while y'all look over it. Please let me know which ones you need me to talk about. All right, so for number 3, if you just cover the triangles, I was helping somebody with this last week. If you're having trouble like figuring out which postulate, just look at one triangle. So everybody look at this triangle. Is the angle in between the 2 sides? No. So then what's that going to spell, Jaden? ASS. Is that one of your postulates? No. So that's not congruent. As soon as you see the angle is not in between 2 sides, it's going to spell ASS, not a postulate. So there's 3. And then for 7, y'all look. You could have, I love y'all, mean it. Honors children. Y'all got the world at your fingertips with these smartphones. You could have Googled what bisect meant. Okay, what does bisect mean? Yeah, cuts it into 2 equal parts. If you looked up bisect in math, like if you said in Google, bisect in math, it says it's something that cuts it into 2 equal parts. So when I'm telling you BD bisects ABC, this angle right here, it means it cuts that angle into 2 equal halves. So these 2 angles should be the same right here. This angle and this angle are equal. So then you have side, angle, side. Does that make sense? Okay, Google is free, y'all. Look up what bisects means. That was a challenge problem. That one was hard. Any other questions on the front before I flip to the back for y'all to check? And then we're going to start next. All right, similar triangles, page 42. So this is your last notes topic for this unit. So tomorrow you'll practice similar triangles, start working on your test review. Test review due Thursday, test is Friday. Okay, I'm gonna get y'all talking a lot today because I'm hoping this is review. Do you guys remember from middle school what similar figures were? Like if I told you 2 quadrilaterals had similarity, does anybody remember what that is? You gonna look it up for us? Oh no, he's getting a tissue. If I say 2 shapes have similarity or are similar figures, who remembers from middle school what that means? You did it in 6th and 7th grade. What's it mean, girl? Yes, good. Similar just means close, right? Okay, so to be more specific, are similar figures going to be the exact same? No, very good. They're going to look the same, but one's going to be smaller and the other will be bigger. Does that make sense? So they're going to have like some of the features that are the same, but the size will not be the same because they're not exactly congruent. So similarity is when two figures have corresponding angles that are congruent and sides that are proportional. You learned about a math concept / term in middle school that had to deal with proportions. I'm being very vague. I'm going to see if anybody can think of the word. I know you did proportions. You started proportions in like 5th grade and did them all through middle school and math 1. Scale factor. Did we learn about a scale factor? You did, especially back when you did units. Soraya's like, Miss Poole, I don't remember that. A scale factor basically just means the proportion between the two shapes has to be the same on all the sides. Okay, so we'll do an example in a second. Couple things I want you to write down about similarity. They have the same shape, but different size. The symbol for similarity is just the little squiggle. So there's no equal bar underneath it. Remember, if it's a squiggle and then an equal bar, what does that mean? Congruent, which means they're exactly equal. Good. You just see the squiggle, that's similar. And then they all should have the same scale factor, which is just a constant ratio between corresponding sides. Really happy. Some of you are like, what the heck? Guess what we have for similar triangles? Postulates. Like side, side, side. Side, angle, side. But the good thing about similar triangles, how many sides does a triangle have? 3. 3. If a triangle is similar and it's not exactly equal to another one, it's just similar, then there are only 3 ways that can happen, 3 proofs, okay? So let's write those down. For similar triangles, there are 3 postulates. Postulates, I spelled that wrong. There we go. That's an E. My spelling is off today. Don't think I'm gonna need to actually write out what these are this time because y'all like know what the S's and A's represent, right? So I was just gonna do like postulate, example, postulate, example, postulate, example. Is that good? Okay. So the first postulate is side, side, side. So let me ask y'all a question. If the triangles are similar, are the 3 sides going to be equal in both? No. What did we write down at the top? Sides are sides. S-I-D-E-S. Are, can you say again? Proportional, very good. Sides are proportional. So we need to review what a proportion is, okay? So everybody with me? All right, so let's go ahead and do an example for side, side, side. Let's say I give you this triangle right here. You are going to have to draw these. A, B, C. This is 24, 32, and 40. And then,
Hey, y'all, pardon the interruption.
hi.
Hi, happy day 2 of Teacher Appreciation Week.
Thank you.
Soda and water and snacks.
Ooh, I'll come pick something out.
All right, come get you some.
Thank you. All right, copy down example 1 for side, side, side. I'll be right back. So when I give you all 3 sides, what sides does it look like correspond to each other? So can somebody raise their hand and tell me 2 sides that look like they correspond to each other? Jordan, what you got, bud? You said AC and DF, right? Very good. Does everybody agree those look like they correspond? Okay, so it does not matter what goes on the top of your proportion and what goes on the bottom. You should have learned that in middle school also. Most of the time, you will see the smaller number on top. Does that make sense? Yes? Okay, so Jordan said 25 should go with 40. Now, if I'm checking to see if these are similar, then I'm going to set up a proportion, which means I set it equal to another pair of corresponding sides. So can somebody tell me another set of sides that look corresponding? What you think, Chris? You said which one? Okay, EF, which is 20. And he said to BC, which is 32. And I do agree, those also look like they should be corresponding because the shapes look the same. The sides just aren't equal. So in middle school, you learned about proportions. This is a proportion because I have 2 ratios set up equal to each other. Now, if there were X's in here, how would you solve a proportion? How though? Cross multiply, very good. We're going to do that in a minute when there's some variables, okay? But then you don't need to cross multiply here. This is just 2 ratios. So we're trying to see, are the ratios, AKA the scale factor, is it the same? If it is, then they're probably similar. So let's check. What's 25 over 40 reduced to? 5 over 8. I'm worried about some of y'all. 5 goes into both of those. That reduces to 5 over 8, right? Okay, what about 20 over 32? What does that reduce to? 5 over 8. Very good. Now, you have to check all 3 sides, so check your last pair. It would be 15 over 24. And 15 over 24 also reduces to. So 5 over 8 is your ratio or your scale factor. If it's the same for all sets of corresponding sides, then these are similar. Similar, not the same, not equal, they're similar. So who thinks they could help me write the similarity statement? Triangle what is similar to triangle what? Who wants to help me write this? What you got? ABC is similar. Very good. To triangle DEF. Just make sure the corresponding sides match up. So if I give you all 3 sides, you're setting up proportions and reducing to make sure they all have the same ratio. Does that make sense? You'll see me put the smaller sides on top and the bigger corresponding ones on the bottom, just because that's what I'm used to simplify, okay? But it does not matter. You could have put 24 over 15. You could have done it backwards. What's going to be the most important thing to make sure you do? Well, yes, you have to know how to simplify it. Can I do 24 over 15 and then the next time do 25 over 40? No, whatever triangle you put on top, those have to be the top pieces all throughout, okay? Any questions on side, side, side similarity? No? Y'all feel like you could do that? Like, do I need to give you one to try, or you feel like you could do it? Okay, they said they're good. All right, y'all. People at home, I hope y'all are good. My little quiet children. Okay, your second postulate. What do you think it is? Side angle side. Good. So side angle side is done the exact same way as side side side. You're going to have to check the proportions between these two sides. But then the angle in between them should be the same. Very good. So let's see if this pair is similar or not. Ooh, that's an 8. 18 and 24. So I'm going to pause while y'all write down those two triangles. All right, y'all. So does everybody agree that both of the triangles are right triangles and they both have side angle side? Yes? Okay, so how do we check if they are similar? The angles are the same. That's good. That's what makes it side angle side. So how do I check if they're similar? What do I do? Set up a proportion and check the scale factor, see if it's the same. So which two sides do you think correspond to each other? Can somebody name me a pair? Very good. Everybody be careful on ones like this where they don't name them for you. 24 is bigger than 18, right? 36 is bigger than 20. So the bigger side should correspond and the smaller ones, right? So let's see. If I do 24 over 36, like she said, and set that equal to 18 over 20, what is 24 over 36 reduced to? It reduces to, what did you say? 2/3. 12 goes into both of them. What about 18 over 20? What does that reduce to? 9 over 10. Very good. Ooh, I'm going to get y'all. We did lots of reducing when we did probability. Don't y'all forget about that. On Monday after your test, you're going to have your first little exam review set of problems. Henry looked so excited. Does 2/3 equal 9/10? So are these triangles similar? No, you would literally just write not similar. You could do the squiggle with like an X over it. Yep. Those are not similar though. So let me go ahead and talk to y'all before we try to guess what our third postulate is. When you are doing similar triangles, if you know any sides, I hope we're all listening, you have to know at least two, because let's think about it. If I gave you angle, side, angle, that means you only know one side in each triangle, right? Can you set up a proportion if you only know one side? Nope. If I gave you angle, angle, side, can you set up a proportion if you only know one side for each? No. So with similar triangles, if you don't know two or more, then they're not going to be similar. Did that make sense? Is everybody following me? So these are the only two from last time that we have. The third one is completely different, okay? Oh, it's not side, side, angle. That would be Ash just backwards. Oh, he said triple A. Okay, hang on. You're close. It's just angle, angle. Double A, like the battery. Sure. If you know two angles in one triangle are the same to two angles in the other one, then that must mean that the third are the same too, right? Because triangles have to add up to 180. You with me, Henry? Triangles got to add up to 180. So if you know two of them are equal to two in another, then that has to mean the third ones are equal. So angle similarity is where we know two angles are congruent to two other ones. So here's an example. These are the easy ones. Please don't ever miss these. I will be sad. DEF to R. Let's say this is 40 degrees and 100 degrees. What's up, bud? The little one's 40 and these are 100. All right, does everybody agree angle D is congruent to angle R? And angle F is congruent to angle S? Good. So are these similar? Yes. You don't have to know any sides. If you know two of the angles are congruent, then that also means these sides that they share would be proportional, okay? That's a proof. If you want to know how, I can show you sometime in office hours or tutoring. I'm not going to waste your time now, though. If you know two angles are congruent to two angles in another, the triangles are similar. So who thinks they could write my similarity statement for me? Somebody different. What you got, Jaden? Okay, triangle DEF RTS. Very good. So DEF RTS. So do you think if I gave you two triangles and told you some of the angles or told you some of the sides, you could test and see if they're similar and then tell me why and write the statement? I only had 3 of you answer. Let's try again. This includes y'all too. If I give you 2 sets of triangles and I give you some of the angles and sides, do you think you could test and see if they're similar? Tell me by which postulate and write the statement. Great. Yes. Good. Okay. So then there's only one other thing I have to show you. Is everybody good? All right. So the last thing we're going to do today is solving similar triangles. I'm going to do like 2 or 3 examples, and then if y'all are good, I'm going to turn you loose. So for each of these, we're going to find the value of x in each similar triangle. So while you're copying down example 1, these are already similar. I already told you in the directions they're similar, so you're not trying to prove that to me. You need to solve the similar triangles and find the value of x. So if they're similar, let me ask y'all a question. What do we know about the sides? Scale factors. Thank you. The word is proportional. If they have the same ratio, aka scale factor, then they are proportional. So we're going to set up a proportion and solve, which Jaden told us earlier. We do that by what? Cross multiplying. Very good. So y'all, what proportion would we set up? Who can tell me what my proportion would be? Soraya, go ahead, babe. Okay, 28 over 36 equals 42. Go back to the triangle you started with. So 28 and 42 should both be on top. Over what? Very good. Negative 5x plus 4. Anybody confused on how I set up the proportion? So left side in the small one goes with left side in the big one. Bottom in the small one goes over bottom in the big one. corresponding parts. Is everybody okay? Okay. All right, how do we solve it? Third time I'm gonna ask. Cross multiply. One of my kids last year was trying to multiply top times top, bottom times bottom. That's not what we're doing. We're not multiplying like the fractions. You are cross multiplying to solve their proportion. So everybody okay? Okay, 28 times 5 should be 140. So that would be negative 140x, right? Then you also have to do the 28 times the 4. Let me do it this way because I got some of you looking at me crazy. 28 is going to multiply by negative 5x plus 4. And it's going to equal whatever I get when I do 36 times 42, right? Okay, I'm just making sure y'all were looking at me weird, like I was doing some voodoo math. Okay, 28 times 5, I know that's negative 140x. What's 28 times 4? 100 and what? 104? Good, I think. I got to double check. I got 114. You're good. I'm going to double check us. We're both wrong. It's 112. I feel dumb. Negative 140x plus 112 equals 36 times 42 is 1,512. And from here, what are we doing? Yeah, you're just solving for x, but some of y'all need to really pay attention because we messed this up on our quiz, which was kind of scary. How do you get x by itself? Subtract 112, good. So that would be negative 140x equals 1,400. And then how would you get x by itself? Divide by negative 140, right? So what would x equal? Very good, negative 10. You should not need a calculator for that one. Y'all gonna make me sad. The top is the same number as the bottom. It just has an extra 0, right? So that means it has an extra tens place. So x would just be 10. Did y'all learn that shortcut in middle school? Okay, good. That's all I asked you to do. I didn't ask you to find the missing side, anything like that. If I did ask you to find the missing side, you would just go put negative 10 in for x, and then you could check your proportions, right? Do I need to do that, or everybody feels like they could do that? I can barely hear you, babe. What'd you say? No, say it. You're just mumbling. No, I didn't give you any angles. I already told you they're similar. So the angles don't matter. Good question. All right. How many more of these do y'all think you need? Are we sure just one? We can just do one. That's fine. And then if you want a third one, I've got one that I can do. All right, let's do this one. So same thing. The triangles are already similar. So y'all draw this one, and then we'll talk about how we would set it up. Maybe some of them are looking at this a little weird, so I want to make sure we understand what two triangles I'm talking about. The little pink triangle is similar, which means it's the same shape, just a different size, right? To the big blue one. Does that help some of you that were looking at it funny? The little pink one is similar to the entire big blue one. They're the same shape, just different sizes. So let's talk about it. For the little pink one, we know 6 corresponds to what side on the big one? 14, very good. And then we also know the little pink one, x plus 5, is the other side, correct? So this is where y'all struggle on this one. What is this entire side for the blue one? Okay, yep, maybe y'all aren't struggling. Look at y'all, smarty pants. The entire side would just be x plus 14, right? Because 5 plus 9. Y'all go with that? So that's what goes in the denominator of your proportion. Anybody confused by example 2, just setting it up? Do y'all need me to solve it with you, or y'all want to try to solve it on your own? Okay, try to solve on your own, cross multiply. I'm gonna pause, but I'm still sitting here. Don't go anywhere because we'll check it. All right, so if you cross multiplied 6 times x plus 14, when I multiplied those, I got 6x plus 84. Is that what y'all got? Okay, and then when I did 14 times x plus 5, I got 14x plus 70. So remember, solving when you've got x's on 2 different sides, it's easier to move the smaller amount. Jordan, you okay, Ben? Where'd you mess up? Did you not distribute? So I'm going to move the 6x's over because that's smaller than 14x. So 14 minus 6 is 8x plus 70 equals 84. And then how would you get x by itself? Subtract 70. Good. Making sure we remember how to solve. So I got 14 equals 8x, and if you divide the 8, I got 1.75 for x. And that's okay, you can get a decimal. What would 1.75 be as a scale factor? Look at your fraction. 7 over 4. 14 over 8 reduces to 7 over 4. If you have 7 quarters, isn't that $1.75? So that's fine, that's a ratio. Everybody okay with that? Any questions on solving similar triangles for the missing x value? That's the only other thing you really can do with similar. So remember what we did first before I let you go do your delta math. The first thing I could do is give you 2 pairs of triangles and ask you, are they similar? If so, what postulate? And then you would have to write the similarity statement, name the triangles. Or I could tell you they're similar and you're solving for x, for a missing piece. Any questions before I let you go work on your delta math? It's only 10 questions. It should not take you long. I think it took me about 7 minutes. So it'll take you like 20.